right, let's look at inequalities. So we could have linear inequalities, and so this is an example. 3 is less than 2x minus 5 is less than or equal to 9, and I can just go through and add 5 to both sides, so I'd get 8 is less than 2x, which is less than or equal to 14. And dividing everything by 2, I would get 4 is less than x, which is less than or equal to 7. And then, so I solved it. Now I need to graph that. So at 4, and then at 7, it's greater than 4 and less than 7. And now in interval notation, a parentheses is where for less than, where it's not including that 4, and then a bracket is including the 4. Now let's look at nonlinear system or inequalities. So with these, we need to set this equal to 0, so I'm going to add 2 to both sides. And now our next step is to find the critical values. Okay, so we're going to set this equal to 0, and then we're going to solve it. So I can factor here x plus 2x plus 1. So my critical values are when x equals 0, and that, or when the equation equals 0, and that happens when x equals -1 and -2. Okay, so that's my critical values. Okay, now what I'm going to do is just figure out when is my function greater than 0. So here's my function, and when is that greater than 0? When is it positive? Okay, so this has a couple different sections. We've got when x is -2, when x is -1, and so we want to think about those sections. So for example, we can test x equals -3. We're going to, and maybe x equals negative, how about 1.5, and then x equals something over here. So easiest one would be 0. So first we set the inequality equal to 0. We found our key points, and now we need to test those points. Okay, so I'm going to just set up a little sign chart here. So my factors are x plus 2, x plus 1, and then the function is x plus 2 times x plus 1. So let's just see what happens here. And because this is greater than, it can't actually equal 0. So those are not going to be part of the solution. Okay, so I'm just going to look and see what happens here at -3. -3 plus 2, that's negative. -3 plus 1, that's negative. So when I multiply a negative times a negative together, that would be a negative times a negative. So that would be positive in that section of the graph. Okay, same thing here, -1.5 plus 2, that's positive. -1.5 plus 1, that's negative. And then you multiply a positive times a negative, times a negative, that whole thing is negative. And at 0, we're positive, positive, and positive. Okay, so now I'm looking to see when is my function, here's my function, when is that greater than 0? Well, it happens twice, here, and then I write my interval. Okay, so this section is positive, and this section is positive. Because of that just greater than, there's no equal, I'm not going to include those critical values of -2 and -1. So my interval goes from -infinity to -2, or I skip over to -1 towards positive infinity. All right, so graphing this, we can solve the inequality graphically as well. So if we're looking to see when is this function x squared plus 3x plus 2 greater than 0, that would be when it's above the x-axis, and it happens in the two sections. So right here and here. it needs to be greater than 0, so that would be an open circle, and the x's that correspond to that place where the function is positive, where it's greater than 0, are my x's less than -2, so from negative infinity to -2, or we skip over and get our x's over here, which go from -1 to positive infinity.